Hello everyone, this lesson we're going to review single-phase transformer. So, when you learn this single-phase transformer in second year, there are two basic formula you need to know. First one is the voltage ratio equal to the turn ratio of the transformer coil. The second one, for isolation transformer, the kVA in must equal to the kVA out. The kVA we calculate in single phase volts times N. So your primary voltage times primary current will equal to secondary voltage times secondary current. So this is a very basic two rule you have to know when you're dealing with single phase transformer. Another thing, we usually talk in transformer, we're talking about primary winding, secondary winding, high voltage winding, low voltage winding. We're talking about primary winding is the winding connect onto the source. The secondary winding will be the winding connect onto the load. The high voltage winding is they have more turns, so when we connect the transformer in the circuit, it will have a higher voltage. The low voltage winding is the voltage on the winding will be lower. Depends on if we're using a step up or step down transformer. If we're using them as step down transformer, the high voltage winding will be the primary winding, and the low voltage winding will be the secondary winding. But if we connect them as step up transformer, then your high voltage winding will be the secondary winding, and the low voltage winding will be the primary winding. Also, when we're talking about transformer, we always have to know the polarity of the transformer. So on the transformer marking, the high voltage winding will mark H1, H2. If multi-coil, it will be H3, H4, or even more. The low voltage winding will be marked as X1, X2, or multi-coil we have X3, X4. The polarity we're talking about is whenever we know the transformer only working on AC circuit. In AC circuit, the instantaneous polarity for H1 will be the same for X1 for our transformer. So that's how we define the transformer polarity. And when we parallel transformer together, we have to know there's few things we have to be really careful. First thing, the transformer primary and the secondary, or the high voltage winding, low voltage winding, must have the same voltage rating. In another way, we can say the transformer will have the same voltage rating and the same ratio between the high voltage and the low voltage. Second thing, we have to know the transformer must have the same percent impedance, because the percent impedance gonna deciding how the transformer gonna share the loads. If they have a different percent impedance, then the two transformer will not be able to share the load based on the kVA rating. The third one, we connect transformer in parallel, we have to know the polarity, the instantaneous polarity of those terminals. Because if you connect them wrong, the wrong instantaneous polarity, you will have a short circuit. So those are the things you learned in second year. We just review down here. One more thing, it's very important, is about the transformer's rating. So I give you an example down here. I have a single phase transformer. The rate for 600 volt to 120 volt. The kVA rating of the transformer is 6 kVA. So if I connect this transformer on 600 volt, you'll get a 120 volts on the low voltage side. And by this kVA rating, I know my primary current will be 10 amps, because 10 amps times 600 volt will give me 6 kVA. Same thing, the secondary side, I can have 50 amps. This 50 amps times 120 volts also gave me 6 kVA. For those volts amp, volts amp. It's the maximum voltage this transformer high voltage side will be able to handle, and the maximum current that coil will be able to handle. So the installation of that transformer winding, we're deciding what's the maximum voltage that coil can handle. And the wire size, we're deciding what's the maximum current that coil or that winding will be able to handle. If we connect this transformer to a 240 volt supply, now our primary voltage will be only 240 volt. But based on the transformer ratio 5 to 1 there, we can calculate the secondary, we only get 48 volts. However, we do the transformer kVA, if we use this transformer to connect a load on there, we have to be really careful. For that high voltage winding, the maximum current, even when we connect in different circuit, the current will not be changed because we use the same transformer, they are same size of wire down there. So the primary winding still only will be able to handle 10 amps. The secondary winding only will be able to handle 50 amps. So if we calculate at this voltage, the maximum kVA will only be 2.4 kVA. So that's a very important idea you have to know, otherwise you will make a mistake. Next one, I'm going to review auto transformer. When talking about auto transformer, there is a direct connection between the primary side and the secondary side. So for auto transformer, part of the energy is transferred to the load. And another part of the energy is directly connected to the load. So when we do the calculation for auto transformer, we cannot using the rule down here. We're talking about isolation transformer, the kVA in equal to kVA out. For auto transformer, because part of the energy is conducted directly to the load, so that formula not going to be able to apply here. I give you one example down here. I have a 600 volt to 120 volt transformer, same as that one, is 6 kVA rated. If I connect this one as an auto transformer, I connect this one in additive. So H1 is connected to X2, so the 600 volt down here, the 120 volts on my secondary side here, the load gonna be seeing both those voltage add up. So my load, we have a voltage equal to 600 volt plus 120 volt, because this transformer is connected in additive way. So now the low voltage will be 720 volts. The maximum current go here. I use red arrow down there to indicate the current direction. So this current from the line come here, come to this point. By using Kirchhoff's current law, this current will split two ways. One go here, another one go down from the secondary winding. The secondary winding, we calculated before, the maximum can handle 50 amps. So that will be the maximum current this load will be able to get. If the current go above 50 amps, we're going to burn out this transformer winding. So that's the maximum current the load will receive. By load receive 50 amps, so the load kVA will be the volts times amp, 720 volts times 50 amp. The load could be 36 kVA. So by using this 6 kVA isolation transformer to connect in an auto transformer, I can have 36 kVA load put on this transformer and without overloading this transformer. That's what I said. For auto transformer, we're not going to using this. We're not going to limit it by the kVA rating of the transformer, but if we calculate by here 600 volt times 60 amps, we will still have the load draws 36 kVA. The input will be also 36 kVA. Just we cannot use the transformer kVA to do the calculation for the load. So the maximum kVA of the load depends on the transformer winding's current rating, because for this transformer winding, it's a rate of 50 amps. In this configuration, my load can receive 50 amps. Here's the review for your second year single phase transformer. If you have any question, you can connect us online or send us emails.